In this lesson, let's see how we can fetch the transaction cost or the transaction fee information from the ledger. Let's remove this code. We don't need this. And let's remove all these things. Let's output whatever is present inside validated ledger. So this is the command, which is server info. Let's output this. We already saw the output in the previous video. Let's check that once again. Let's run the compiler, which is TypeScript compiler. And then run our code present inside dist folder. Now we need this value, the value present inside this field, which is base fee XRP. Let me copy that and fetch that information, and then let me output whatever is present inside info, and then change this label to base fee. We need this. So let me comment this out for now and output whatever is present inside this info field. Inside all these, we need this load factor because the transaction fee depends upon the load factor too. So now let's calculate the current transaction cost in XRP based on these two fields, which is this one, the base fee in XRP. Remember, it's in XRP and not in drops. Multiply it with the load factor. So let me remove this. This should give the current transaction costs in XRP, which is 10 drops. This is in XRP. To convert it to drops, let me show that to you. Let me bring up my calculator. So I'll convert this XRP value into drops by multiplying it with 1 million, because 1 XRP is equal to 1 million drops. So this represents 10 drops. As you can see, the transaction cost depends upon the network load. The load factor is very much important here. That is because, take an example wherein a person has 10,000 XRP. He or she can just start sending one drop continuously, programmatically start emitting that. Let me bring up my calculator and show you the math. Let's just take 10,000 XRP. So divide it by one drop. So 10,000 XRP means these many drops. Now divide it by 1,500, because that's how many transactions one ledger can handle, right? And a ledger closes every 4 seconds. So you can even add the transaction cost. If it remains 10 drops throughout for all the transaction, even then somebody with just 10,000 XRP could just hijack the network for months. Okay, so this can be easily avoided by including this load factor. So once the load increases on the network, so obviously since this is multiplication, the transaction costs also goes up. So that way nobody can just abuse the network. If they want to abuse the network, they will first be abusing themselves, their own wallet, right? Because the transaction costs would be so high that they would be paying more transaction cost than what they are emitting. If they are continuously trying to emit one drop, the transaction cost will be a couple of XRP if the load is too heavy. So first of all, the Ripple server limits the rate at which API clients can make requests on public APIs. The rate limit is based on IP address of the client. But still, that can be tricked by using VPNs, and you know it, right? So that's the basic security. The second security is that the fee is based on network load, which protects against ledger abuse. Now, this is one way of calculating the current transaction cost in XRP. So there is another command, which I'll show you here. So this is the URL, and this is the command, which is fee. So what does it do? The fee command reports the current state of the open ledger requirements for the transaction cost. So let's check that out. Let me output whatever is present inside this fees. So we have base fee, the transaction cost required for a reference transaction. By the way, reference transaction means the regular payment transactions. So base fees means the transaction cost required for a regular referential transaction to be included in a ledger under minimum load. And also remember, there are the transaction fees are different for a couple of transactions, and I'll let you know that shortly. So this is for payment transaction, mainly for payment transaction. So what is median fees? An approximation of the median transaction cost among transactions included in the previous validated ledger, okay? Previous validated ledger. So that's median fees. And the minimum fees, the minimum transaction cost for a referential transaction to be queued for a later ledger. If this minimum fees is greater than the base fees, then the transaction queue is already full. So these are a couple of informations we can get from the fee command's output. Also note that a transaction can have three states based on the fees, that is, transaction that specify a transaction fee so low that they get rejected straight away. The second state is the transaction that specifies a transaction cost high enough to be included in the current open ledger. And the third state is the transaction in between, which gets queued for a later ledger version. So these are the three states of a transaction which is based on their fees. Previously I told that some transactions have different fee structures. So let's look at that. Why not look at it on the official documentation page itself? So let me open that up. This is the URL of the page. Reference transaction, which is most of the transaction like payment transaction, cost before load scaling means this is the minimum cost, that is 10 drops, which of course varies depending upon the network load. And key reset transaction, there is no cost, 0 fees. I'll come to that later on. Multi-signed transaction fees can be calculated using this formula. Escrow finish transaction with fulfillment, this formula. And account delete transaction takes 2 XRP as of now. Best practice is to calculate the minimum, medium, and higher fees and allow the user to select the fee by themselves using a drop-down menu in the UI or something like that. So that's all about fees as of now. And 3 important things which are very basic and I want to reiterate it. That is, the transaction fee is not paid to any party. There is no mining in XRP ledger and all transaction costs are burned.